Good day, everyone. I am Lamadora, and today I'll be talking about one of the most important forces in the universe, the gravity, and the concept of the gravitational field. So, first, what is gravity? Gravity is the force that pulls objects towards each other, especially towards the center of the Earth. For example, when we drop a ball, it falls down, not up, because the Earth's gravity pulls it. Without gravity, a lot of things we considered normal would be impossible. We wouldn't stay underground, we would float into space. Planets wouldn't move properly in orbit around the sun, and the universe would have no order. That's why scientists use the concept of the gravitational field to explain how this pull works between objects, even if they are not touching. What is gravitational field? A gravitational field is the region around an object where another object experiences the force of gravity. Let's imagine this. Every object that has mass, like the Earth, the Moon, or even you, creates a gravitational field around it. This field is invisible, but its effects are real. You can't see Earth's gravitational field, but you can feel it every time something falls. For example, when you drop your phone, it doesn't just fall randomly. It moves straight towards the ground because the Earth's gravitational field pulls it towards the center. Even the Sun has a gravitational field, and it's so strong that it keeps all the planets orbiting around it. So, a gravitational field is basically the invisible zone of attraction that surrounds any object with mass. Now, how strong is the gravitational pull? That's what we call the gravitational field strength, represented by the letter G. It measures how strong gravity is at a certain place, and it's defined as the force per unit mass. In simpler terms, it tells us how much force acts on every 1 kilogram of mass. On Earth, the gravitational field strength is 9.8 meters per second squared. This means that when something falls, its speed increases by 9.8 meters per second every second, ignoring air resistance. For example, if you drop a ball, it will keep falling faster and faster because the Earth's gravitational field is pulling it down strongly. That's why objects fall, not because they want to, but because the gravitational field accelerates them towards the center of the Earth. The gravitational field actually represents the force of attraction between masses. What's amazing is that objects don't need to touch for gravity to act. It works even across empty spaces. Let's look at some examples. A ball falls when released. When you release a ball, it falls to the ground. That's the gravity pulling it down. Example number 2 is the moon stays in orbit around Earth because Earth's gravity is pulling it inward while the moon moves forward. Example 3, the Earth stays in orbit around the sun. This, the Earth stays in orbit around the sun. In the same way, the sun's gravity keeps it from flying off into space. So, gravity acts at a distance. It's an invisible connection between objects that have mass. Gravity doesn't choose. It affects all objects that have mass, no matter their size, shape, or material. This means everything from a small pebble to a huge planet experiences gravity. One famous example is the feather and stone experiment. In a vacuum, meaning no air, if you drop a feather and a stone at the same time, they will fall at the same speed. This shows that gravity acts equally on all masses. It's called universal interaction because it happens everywhere in the universe and affects all matter. Gravity is not just a topic in physics, it's something that affects our daily lives and the natural world. Here's why it is important. Gravity keeps our atmosphere around the Earth, so the air we breathe doesn't float away into space. It keeps oceans and seas in place. Without gravity, water would drift off. It causes tides, which happen because of the gravitational pull of the moon on Earth's oceans. It allows satellites to stay in orbit, which helps us use GPS, communication signals, and weather forecasting. So, gravity is not just a force, it's something that helps life and technology function properly. Without gravity, life as we know it would be impossible. Now, let's look beyond Earth. In space, gravity plays a massive role in shaping the entire universe. It holds the solar system together, keeping the planets orbiting the sun. It helps in the formation of stars and planets. When space dust and gas come together under gravity, they form stars and worlds. It keeps galaxies bound together so they don't scatter across the universe. Without gravity, there would be no stars, no planets, no galaxies, just floating matters with no structure or order. In short, gravity is the architect of the universe. It gives everything shape and organization. To summarize everything, the gravitational field explains how objects attract each other without touching. It tells us why things fall, why we stay on Earth, and why planets and moons move in the way they do. Gravity connects everything, from the smallest pebble to the largest galaxy. It's the reason the universe is stable and life is possible. Without gravity, nothing would stay in place. Not us, not our air, not even the planets in space. So, in simple words, gravity is the invisible force that keeps the universe together. The reason we exist, the reason we stay grounded, and the reason everything moves in perfect harmony. And that would be all for my report. Thank you for listening. I hope you learned something about how gravity truly keeps our world and our universe connected.